So in the last video we have covered geometry, we have talked about ship, we have talked about creating geometry like bubble ground, blobs and tubes. And in this video, it should be a lot shorter, we'll cover simulation, Vellum simulation itself. This geometry node contains of two simulations for two shots. The first one is for the first shot, and let's start with the first one. So we have a bubble ground created earlier. I have shown it here. This is how it looks like. And here I'm importing it using the object merge node, and I have changed transform into this object, and then I'm remeshing it. And the reason I'm remeshing it is because Vellum solver greatly appreciate a triangulated mesh instead of quads. So here it looks like now. And then I'm using a group node to select outer edges. This is to make sure that this is to make sure that the whole mesh didn't fall onto the ground and that it will stick to this group, to these edges. And it will stick to these edges. And the way I have done it is I changed the group type to edges. I have disabled a base group, and I have enabled include by edges, and I have just checked and unshared edges. And Houdini does everything for you. And then I have created a cloth Vellum constraint with these values. I will not go deep inside why I have chosen these values. This is a purely trial and error. So yeah, here is how the stiffness looks like. By default, it's set to maximum. I have decreased the damping ratio, so the cloth. Oh, I won't be explaining. Just watch a tutorial explaining how Vellum works. It will be much better than me explaining it. And I have also increased the stiffness to the maximum. By default, it was like almost, well, it was so low. And then I have used pin constraints, which is the early created group. Not sure why it's using two groups actually. Interesting. Never mind. Okay. Yeah, I guess it should be like this. And here how it, if you want to visualize it, here how it looks like. And the constraint type is set to pin to target. And then the Vellum solver comes into play. And if you preview it, here how it looks like. And by the way, under the first Vellum constraint, we have a ship, which is also imported with the object merge. And we place it under the third input under the Vellum constraint, which is basically a collision geometry, as you can see here. And the Vellum solver, I have disabled the wind, and I have increased the substeps to 4, and that's it. Oops, I'm sorry, nothing more. And then I have cached out the simulation. And under advanced settings, you can also initialize simulation OPs. And by default, and I also set the final frame to, and I also set to cache it for 50 frames only, because the shot itself is like 10 frames or 12. And then I can also use the Vellum post-process. And then I have used the mounting sop just to make it a little bit, just some like some sort of texture to it, so it's not so smooth. And I have added a null to use it later in the rendering. And that's pretty much it for the first simulation. And what about the second simulation? I have used the bubble ground SOP HDA, which I created earlier, but this is because I didn't want to use the same pattern, like this views pattern. I want to make it a little bit different like this, and we can play around with it. I have used the transfer SOP to flip it, and then I have used the remesh SOP. And here, what is the interesting part? I have used an edge fractured SOP, and if you visualize it, here's how it looks like. And it's basically fractures the edge. You can watch much better explanation tutorials on what it does and how it does. I will here just show what I have done with it and how. So here I created a draw curve SOP, and basically you can draw a curve, and edge fracture SOP will create a fracture, and curve looks like this. And under the curve I set the projection to XY XZ plane. By default it was something different. And then I have outputted a pieces group. And then I have used similarly to the previous simulation Vellum constraint SOP. And then I have attached those points. And then I have used a stitch Vellum constraint, which is basically sets constraint type to weld points, which is basically welds all the fractured edges. And here's the Vellum solver. Oh, and by the way, in the Vellum stitch, I have enabled the breaking with this threshold, and I have also I actually haven't used break threshold anywhere. I thought I had used it, but never mind. And I have changed the type to stretch distance. By default it was something different. Stretch stress. So, and if I preview it, here how it looks like. And then I have cashed it out, 100 frames. I have used the mounting SOP also. Vellum post-process again. And if we merge everything together, oops, like that. This is how it looks like. And here's the ship itself. You can also use a paint attribute and mask whenever the bending will be happening. And under Vellum constraint, the first one, you can use a scalable attribute, and you have you can use this bend stiffness attribute, and you can use it in the paint attributes, and then just use this attribute instead of the default mask. And that's pretty much it. Hit enter to start drawing. Middle mouse is a brush radius. But in my case, for some reason, where I have used Activate Paint, the simulation time was tripled or quadrupled. So it basically like simulates forever. And I haven't figured out why, so I haven't used it, unfortunately. Yeah. So this is pretty much it for the simulation part. And hope you liked it. I'm sorry if it was a little bit boring. But yeah, see you in the next video where we'll cover layout, lighting, rendering, and materials. Thank you for your trust and have a great day.